Anytime there's something new that comes out that's supposed to like solve your problems, you always want to, okay, I want to do the same thing I'm doing now, but with newer technology.
This is DevOps Paradox, episode number 275, Managing Modern Infrastructure with GitOps. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. Victor, how much do you know about the origin story of GitOps?
Depends, what do you mean by origin story? Like the term GitOps or the real origin? And everybody's going to freak out here with Chef and Puppet. I feel that those are the first GitOps tools. Except that there was no Git at that time.
There was no Git. There was only Subversion and CVS. Why are we asking this question? On today's show, we have Christian Hernandez on. Christian, how you doing?
I'm doing well. How are you guys doing?
Very well, thank you. So Christian currently works with Acuity, one of the companies that's commercializing Argo CD. And any of the other Argo products? I've lost track now.
Yeah, so Acuity was founded by the creators of the Argo project. Argo project was created internally at Intuit, and those engineers and managers broke off and started Acuity based on the Argo project. But you're not too far off. Our focus is mainly on Argo CD, for sure.
Which is a GitOps tool.
Yes. One of the most popular tools, I think, I wouldn't say this if I didn't have data to back it up, but it is the most popular tool, as in it's the third fastest growing project in the CNCF based on some data they released out. And it's the fourth largest in the Linux Foundation in general. So it's kind of interesting for it to be the Argo project, but Argo CD in general to be included in the same sentences and the same breath as the Linux kernel and Kubernetes. Like those are like massive things. And, Argo is there as well. So it's almost humbling. When you're on the grind, you tend not to look back and seeing like all the work that you've done. But yes, I would say it's the most popular. But if you don't believe me, you can research that. I have data.
That's relatively easy to research since, by my count, there are 3 GitOps tools in total. I will die on that hill. Whomever tells me that there is the fourth one, I will strongly disagree, right? And out of those 3, one is kind of basically not used by anybody, being Rancher Fleet, meaning that it's Argo CD and Flux, essentially, right?
Yeah, and those are the 2 big ones, yes. Yeah.
Enough product talk. GitOps. We've talked about it before, but you're one of the first guests that we've had on. I don't think we've had anybody else on from Flux. Have we, Victor? I don't think we have.
I don't know.
Associated with the Flux project. So this is about as close as it gets. What is GitOps and why did it start? And again, Victor said it, Chef, Puppet, all those things were GitOps before there was Git.
I do think it's important to talk about some of the things we've done before, right? I do think Victor has a very good reason for bringing up some of these tools. I was a huge Chef user, and I've used Puppet before in my background, in my earlier works back when I was used to managing systems, where there was always this need to massively manage infrastructure. And that need always existed, like even when you're racking servers, right? Even when you had, they had the pets versus cattle discussion where like you were even racking servers. Even then, I was using Puppet to manage those servers. And I think virtualization compounded that need because then the background, like I always like to talk about like virtualization and like going back a little bit when I'm talking about GitOps, because the need was always there to massively manage and provision infrastructure for deploying application workloads. And that was especially true during the .com boom. And even after that bubble burst, people still had that aggressive growth mindset. Maybe we're not there anymore in industry, but we've had that aggressive growth mindset. And so that means more infrastructure, more things that you needed to manage. And so tools came out to do a lot of those things. I started off managing Solaris systems with SSH bash scripts, going out and and provisioning those. And, when I saw something like Puppet, I first had my hands on Puppet, I was testing on Puppet, and, that was great. The organization I was working with at the time, we actually found out Chef. We were making a big push to do Ruby on Rails at that time. So Chef made some sense just because it's just like Ruby essentially under the hood. If you didn't have a module for it, you can just drop into Ruby and do whatever you'd like. So we were using Chef a lot of the times. And that was kind of like the birthplace of this idea of managing infrastructure as code, right? This is where the infrastructure as code kind of idea came from. A lot of challenges came with that. And then the challenges wasn't in the software and wasn't in the idea itself, because infrastructure as code, it's like, okay, yeah, I have infrastructure as code. And when things like GitHub and Git got really popular, I remember doing the move. You guys mentioned SVN, but like I did like RCS to like SVN. And eventually the migration from SVN to Git was actually pretty massive in the organization I worked with at that time, because we did that move from SVN to Git, and I had to move from RCS. So this is just like really old story. So we would store our configurations, we would version them and we would store them because we would want consistent way of deploying and managing this infrastructure. But the challenge came not in that process, not in the infrastructure as code process, but actually in the infrastructure itself. Because the issue with virtualizations and VMs and rack-mounted bare metal servers, what you're treating as pets versus cattle, is that they weren't really immutable. Meaning that I can log into a server somewhere and make a change that Chef cannot correct. And that happens a lot. I mean, they're full-blown operating systems. I can go in, change the root password, change the etc shadow file, I guess it is, to make it immutable. And no matter how often you run that Chef script, no matter how often you run Puppet, no matter how often you run Ansible, that password is never going to get reset back because that file is now immutable. So we didn't have the immutable infrastructure. So a lot of those challenges were there. I think a lot of people, when they first hear about GitOps, it's like, well, like, weren't we already kind of doing some of this stuff? And the answer is, yeah, like we were. I don't think we weren't doing it. I think the idea was always there. It wasn't really until Kubernetes came along and really introduced the concept of immutable infrastructure, meaning that if I go in and make a change to a container, Kubernetes will just restart it. It doesn't matter. It's immutable. That container, I can blow it off and it can come back, and my workload was not affected, right? The workload just continues to run just because the immutable aspect of containers and the orchestration aspect of Kubernetes, along with this declarative design, right? Like, it's always the Kubernetes aspect of the declarative design of running infrastructure. It's like you just kind of described your end state, right? If you think about what are these objects that you're creating Kubernetes, you're creating a service object, you're creating a deployment object, and those are just end states, right? It's just YAML. I mean, you can do it in JSON too, but I think we all just agree. In general, when we talk about Kubernetes, we're talking about YAML. And so it's just YAML, and it's just a declaration in a YAML file. So the Kubernetes really came along, and I think that was like the game-changing aspect of it, is that it was just declarative, along with immutability with containers. I think those two things together create a really powerful system. Take the good and the bad with Kubernetes, take all of that aside. I just think the power in having immutable infrastructure, along with the orchestration declarative way of doing things, was a big change.
I would slightly modify that statement and say that the reason for Kubernetes succeeding in immutable almost everything is mostly because it forced us to do that, right? Imagine before containers, right? Before Kubernetes and all this stuff, there is nothing preventing you from having immutable VMs. You want to make a change, you build an image, just as you're building container image, you replace your node or nodes with the node based on the new image. You can essentially do the same thing with VMs as we are doing with containers. Now, I'm ignoring that it takes more time to build VM image and start. But if you ignore the startup times, we can do essentially the same. And that leads me to think that the reason why we adopted immutability only later is mostly because we were forced to. Kind of. With containers,
yeah, there was no other way of doing it.
Exactly, but ignoring some tricks and stuff like that, yeah, you need to be immutable, right?
Yeah, and it did force us to do it that way because there was no other way of doing it. I really like how Kelsey Hightower puts it. It's based on promise theory, right? Like, as long as you give me this, I will do this. And there's no other negotiation that goes along, right? It's like, you give me this and I make sure it runs and that's it. You're giving me something else, I'm not going to run it because it doesn't conform to what I'm expecting from you. But you're right. You're absolutely right. It forced us to rethink how we approach infrastructure. And it made us rethink it. However, we were still doing things the old way. I'm also guilty of this as well. Anytime there's something new that comes out that's supposed to like solve your problems, you always want to, okay, I want to do the same thing I'm doing now, but with newer technology. And not to fault anyone, not to like fault end users or anything like that. Because I said before, like I'm guilty of the same thing. It's like anytime I'm doing something new, it's like, how do I do what I keep doing except with new technologies? But people were still using imperative tasks with Kubernetes, even though Kubernetes is a declarative infrastructure, meaning that in their CI/CD pipelines, in their processes, it always ended with kubectl apply, blah, 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 right? kubectl edit. Everyone had kubectl. We switched from using SSH to now using kubectl. Our mind really didn't shift. Our interface shifted. It's like, okay, I can't SSH, fine. I'm using kubectl, but I'm causing the same issues by using kubectl. And so the idea was that, okay, like I have this immutable declarative infrastructure, as Victor said, I'm forced to use. How do I manage this, right? And so there was a very, very cool story. You can Google it, from Alexis Richardson. Alexis Richardson was the CEO of the former Weaveworks, who I guess at that time, I think they were doing managed services or some sort of managed services, and they lost the famous story, right? Someone fat fingered a config. They lost US East 1 or whatever they were, and they had an outage and they were back like in 30 minutes. Alexis Richardson just asked, usually when you have an outage, usual CEOs are upset, but he asked, why did we come back so quickly? That was his first question, like, how did we come back so quickly? Because that's impressive. He was expecting to be down for hours. He was only down for like 30 minutes or so. And most of that time was spent like restoring backups from S3. But the infrastructure itself was really up really quick. And he asked, and his engineers kind of like described what they were doing. And he coined the phrase GitOps. He goes, oh, that sounds like, at that time, DevOps was really, really hot. New keyword, new buzzword. And he kind of coined the phrase on top of that. He goes, oh, you're like not doing DevOps, you're doing GitOps. Everything was managed through Git. And so he coined the phrase and popularized it for sure. And as other people started investigating how you manage declarative infrastructure declaratively, not imperatively, not with kubectl, some of these things started coming up. Some of these practices started coming up. Kelsey Hightower said once, I like quoting Kelsey because he always has great one-liners, but he said once, is like, Kubernetes is a system designed if I took away SSH from you. Like if I took SSH from you, how are you design a system? And that's Kubernetes. And so I like to like amend that, saying like, GitOps is what you get when I take away kubectl from you. Okay, so like now you don't have SSH. I'm also taking away kubectl. How do you manage a system? How do you manage that? And so a lot of us who were early on in this buzzword era of GitOps back in 2014, 2015, around that time, give or take a year, we all got together from the communities, because the community, Flux community, got together with the Argo CD community. There was folks from Red Hat there was folks from GitHub, Microsoft, AWS. There was like a really large community working group that we built around GitOps. And our first thing was define what GitOps is. And the reason we wanted to define what GitOps is because we didn't want to happen to what happened with GitOps, what happened with cloud. So if you think about cloud, if you say cloud, what does that mean to you? What does cloud mean? Can you define cloud? No, you can't, because like everyone decided to have their own definition of it, right? Every product, when marketing gets their hands on something, right? You want to make sure you attach a buzzword like, oh yeah, I have a cloud here, and it's just like a storage system sitting under your desk. We understood it's a buzzword, but we didn't want it to only be a buzzword, right? We wanted to get individuals together. And so when we formed people from the Flux community, from the Argo community, again, all the parties that were involved, there was a lot of them, came up with basically the open GitOps principles is what we call them. So the GitOps, like, how do you know when you're doing GitOps? How do you know, like, so am I doing GitOps? That was actually the question that sparked getting those principles up and running, is people were asking, well, am I doing GitOps? I'm storing my configuration in Git. I fire off GitHub Actions and it applies it. That sounds like GitOps to me. And so we're like, okay, like, let's define what GitOps is, because I don't want to say confuse it, but people mistake it for like, oh, that's just like infrastructure as code. And it's like, not necessarily infrastructure as code. Infrastructure as code is part of GitOps, but doing infrastructure as code alone isn't only GitOps, right? And so the principles that we came up with is that there were 4. The first principle is that it's declarative. A system managed by a GitOps must have its desired state expressed declaratively, is what we say. Meaning that this is pretty standard, right? This is Kubernetes. This is, I mean, everyone already has them declarative.
That's the part that I might pick a fight with you.
Do it.
I would say that, and I'm being now stricter for definitions, right? I would actually argue that YAML, JSON, XML, declarative. Helm, not declarative.
Yeah, I think I agree with you. Okay,
yeah. Cool.
No,
I wanted to fight. Come on.
And there's actually, if you wanted to, if you know, you're talking about getting a Flux person, like, this is something that both the Flux community and Argo CD community differ in terms of our approach to Helm and how we handle Helm, and our, like, I don't know, religious philosophical view is on Helm, because Argo CD doesn't actually use the Helm SDK directly. It does not use it at all, whereas Flux does. People ask, well, what's the difference to Flux and Argo CD? Well, on Argo CD system, there's nothing there. When you do Helm LS, on a Flux system, there is, because Flux uses it. And why does Argo CD use that? It's because it only wants to work with YAML, and that's it. And so even if you give it a Helm chart, it'll render those Helm charts before it applies it, because we don't want a mutation to happen. Just because of the nature of the programming aspect of Helm, I would agree that, you know, and maybe my personal view, I don't really use Helm all that often. I barely use it, just for the alpha meshing thing. So maybe we'll fight about something else, but that's something I do agree with. And that's the first principle. So going back to the principles, that's the first one. It's managed declaratively. And so that's kind of like the JSON YAML aspect of it. No scripting essentially is kind of what we said. I guess you touched on the Helm aspect of that. But the second principle is that it's version and immutable. And that's where the Git aspect of it is. Desired state is stored, and notice they built on each other, but the declarative desired state is stored in a way that enforces immutability, versioning, and retains a complete version history, which is what Git is. We don't explicitly say Git, even though people are just going to be using Git. S3 is compatible, so S3 falls under that umbrella. A version immutable. SQLite technically does too. We wanted to make it accessible for everyone. Our goal wasn't to force people to use tools, is mainly a guiding principles on like how to manage a system. The third one, I actually do want to, maybe Victor, how you have an opinion on this, because I actually don't like how this is worded, even though I helped author it. I still to this day, the third principle is pulled automatically. People get confused when I say pulled automatically, because when you say pull, people think like a push and pull design in terms of how to apply the manifest. And it has nothing to do with that, actually. It has to do with software agents automatically pull the desired state declarations from the source. Meaning that we don't necessarily care how you apply them, whether you're reaching out to a Kubernetes system and deploying it that way, or if you're using kind of like an agent and you apply it like locally, right? Like it's a pull design versus, we don't care how you apply it. We care about how you retrieve the changes once they are made. And this is to differentiate it from an event-based kind of workflow. Like webhooks is like, if you're just using webhooks, you're not doing GitOps. You will use webhooks for sure in your design, but relying only on webhooks isn't GitOps. And that's where the third principle comes in. I don't know what your opinion is on that, but I really don't like the word pulled. I don't know how else I would have phrased it, but that's the third principle.
I'm guessing that the point over there is that, you know, if you get notified of the change, there is no guarantee that actually you will pick a change. 1,000 things can happen to webhooks. I'm going to simplify it now and ignore Kubernetes. If you just have a cron job that every minute goes to the Git repository wherever you're storing, you're guaranteeing that actually you will have the desired state always, right?
Always, yeah, correct, yeah. So always have the desired state somehow locally, and that's kind of like where you pull those. You will have webhooks, right? Like if I make a change, the webhook changes from like pushing the changes to kind of just notifying the GitOps controller to pull the latest.
But that's more kind of to speed up things, right? Kind of.
Yes,
you do
correct.
pulling every X minutes or whatever it is, but hey, so that you don't have to wait, I can actually speed up the next iteration in a way rather than rely on it, right?
Correct. Yeah, correct. You can speed it up or you can just wait, but the webhook is mainly there just to speed up the reconciliation loop timeout. Speaking of which, the fourth and final principle is that it's continuously reconciled, meaning that it's the observation. So that's kind of like the important aspect of it. It kind of differentiates it from kind of like what you're talking about, the cron job, where it's like if you just cron kubectl apply, or like you said, take Kubernetes out of it, just cron the application of whatever changes is there, is different than observing the state and deciding on whether or not to actually act on it, right? And so that's what continuous for us, our definition is software agents continuously observe the actual system state and attempt to apply the desired state. So if there's nothing to change, then don't change it. If there's something to change, then we will.
My interpretation of the last one is, given that we are talking about Kubernetes, right? My last interpretation of it is that rule is there to prevent people from actually to help people avoid locking down Kubernetes cluster and people from using kubectl, right? Because
essentially, yeah,
right.
Exactly.
If I would have zero access to the cluster, then there wouldn't be that need for continuous reconciliation, because once you reconcile, Kubernetes will ensure that that thing is there forever and ever, right?
Yeah.
But then there is kubectl. So it's undoing kubectl. That's the tagline.
Yeah, undoing kubectl, exactly. And then there's out of band changes, right? Like I can come in and change the scale, and it's like the GitOps controller says, nope, I'm gonna change it back. I'm gonna reconcile that divergence, right? Instead of waiting for a process to kind of see it and change it or alerting, it'll change it for you. Or other robot systems, like other automated, so it doesn't have to necessarily be kubectl. It could be API calls from another system that can change that. But like you said, it's like remove the need for kubectl. Like you still have it. I'm gonna undo your changes.
It's like saying, kids, go, you can play. Daddy is going to clean up the mess after you, whatever you do.
Yeah, exactly. Just go and do your thing. Actually, the analogy I really like to make about the open GitOps principles themselves is that I compare it to the closed loop system, which is basically, I always talk about air conditioners. Back when I used to live in an apartment, going to college, you have the wall mounted air conditioner. I'm pretty sure your listeners can imagine this. Like it's in the wall. I get warm, I get hot. I'm going to stand up. I'm going to go turn it on. The air conditioner's on. I'm like, you know what? I'm cold. Let me get up, go over there and turn it off. And that's an event-based system. Something made me, there's an event. I got warm. I stood up. I have to turn on the air conditioner. Whereas GitOps and Open GitOps in general kind of just modeled after the thermostat, essentially. It's like you set your temperature. I set my desired state. I set it to, Victor, you're in Barcelona. I set it to like 21, right? Degrees Celsius or 22. I like it a little warmer. But I set it once. That's my desired state. And I sit down and the air conditioner's like, will continuously monitor the temperature, be like, oh, it reached above a certain threshold. I'm going to turn on the air conditioner. All right, now that it's 22 degrees, I'm going to turn it off by itself. That's kind of the analogy is wall mounted versus thermostat. And I think that's the analogy I like to make.
The summary of that example is that, man, you need a better air condition. Like,
yes, yeah,
mine
better
is
air
keeping the
yes.
temperature. Let me tell you that.
Okay, yeah. Yeah, no, I have always thought on like, well, I need like a better analogy, but that's like kind of the one I came up with. But yeah, back then the air conditioners weren't that great, so I don't know, maybe some wall-mounted air conditioners do monitor the temperature, but that's kind of like the idea. It's the thermostat aspect of it. You set your desired state, and it'll turn off and on by monitoring the ambient temperature in the room, and it'll make that decision for you versus, you having to get up and turn it on because you're hot, or you have to turn it off because you're that event, right? Event-based versus reconciliation loop. So that's really kind of like from a high level, stepping back, those are the things that the Open GitOps project started. So for anyone who's curious, if you go to opengitops.dev, there's our website with information about, how to join meetings, discussions, things like that. We mainly get together and talk about like best practices or like what are people doing, how to incorporate other things into a GitOps paradigm, right? Like going back to the VM conversations, okay, like how do we GitOps other things in the infrastructure, network switches? How do we incorporate VMs or bare metal? How do we start like getting practices around some of those things? Because this is all rooted, like when you hear GitOps, it's really, really rooted in Kubernetes. And I think it should grow beyond that. I think we have the technology to kind of like grow beyond just containers and Kubernetes.
I imagine that there are two main reasons for that. First, because there are so many things baked into Kubernetes that ignoring those things and building something like Argo CD without Kubernetes would be incredibly harder, right? Because there are simply a lot of mechanism already there, right? And also, I feel that we did ourselves this favor in a way that by thinking about Kubernetes as something that manages your containers, which is definitely the case, which is definitely true, but it's really, I would even argue, I'm actually willing to place a bet that Kubernetes API and scheduler is going to outlive containers at some moment in the future, right? Because it's really more about that API, at least from my perspective, and how we manage state and how do we do reconciliation of something. And then containers happen to be the first implementation of that something. Tomorrow it will be WASM, right? And day after tomorrow it will be infrastructure or whatever, right?
Yeah, and I think that's kind of like the power of Kubernetes. And more and more, I think with them adding custom resource definitions, my personal opinion, everything should be a CRD. Pods should be a CRD, everything, right? And then just Kubernetes just becomes, like you said, like an API layer on how to orchestrate and manage things. Like it doesn't have to be containers. Like it can be whatever the CRD defines, right? That's like, you delegate that to whatever controller is doing that, which we're seeing already, right? We're seeing a lot of that already.
Oh, yeah. But one of the biggest challenges of Kubernetes actually back in the day was to remove all hard-coded Docker instructions in the code.
Oh, yes. Yeah, I remember. I remember there was a lot of that in Kubernetes.
Oh,
You're
yeah.
Right. I remember looking at whatever that directory, Etsy Kubernetes manifests directory, and looking at the YAML file. I was like, wow, there's a lot of shell scripting. No, I do remember that, removing a lot of that logic out of Docker exec commands. And, I mean, we saw a lot of that with like the CRI and CNI and a lot of these like plug-in type of models of like managing infrastructure now with Kubernetes. It's like, okay, we need to make it generic enough to where it's like we're not just relying on like some scripting or one implementation. Like we can have a lot of implementations.
I want to go back to the 4 points. The first 3 points are easy. Declarative. What was the second one? It was another big word.
Versions,
declarative.
immutable.
Versioned. And then polling.
And
Right.
then polling, yeah.
Again, polling should die. But if you want to get the right data, polling is the right answer.
Yeah.
99.999% of the
Yes.
time. Right. It just is. But it's that fourth point. People argue that, hey, I'm doing GitOps. And it's like, okay, any change you make will automatically revert and do anything that's done by hand? No, we need to be able to break the glass. Then you ain't doing GitOps.
Actually, you can, there is always the possibility of a need to break glass. And I feel that people misunderstood the whole story, right? You can break glass with GitOps, right? Nothing prevents you from stopping reconciliation and saying, okay, the hell with all that. We're SSHing into that beast, right? I'm not saying that you should do that, but you can break glass with anything, and that includes GitOps.
And you will do that. And then there's interfaces to like Flux and Argo CD where it's like, all right, stop reconciliation. This is an emergency. I need to go in and make that manual change. But you do need to reflect that back, right? With the idea of like, okay, I made a change to the system. Let me commit that to Git, go through your CI process for Git, and then turn back on reconciliation. And by that time, it's doing nothing because you've already made that change, but it needs to be reflected back. The idea is being reflected back to Git. But you're right. It's the continuously reconciled. I think people, are doing like, yeah, I'm doing 1, 2, and 3. I'm doing a lot of this already. But the continuously reconciled, I think it gets what at first, and I don't see this a lot anymore, but at first people's hesitations was like, I don't want things changing to my system without me knowing. And I don't trust this automation without fully grasping or getting why it's there and why that control is there. They feel like they have less control, but you actually have more control that way. It was a paradigm shift for sure.
I feel that that's the obstacle for people on many different levels, right? Starting with Kubernetes, right? People want for very often something equivalent to Terraform Plane with Kubernetes. Well, it doesn't matter what you're doing with pods or whatever, right? And it's very hard to let go. I trust this thing. Right? It's almost like having a senior, super senior principal or whatever guy, the person that knows something inside out, and you say, I trust you. Do the right thing, right? That's more or less the philosophy of Kubernetes and many of the things that came afterwards or on top of it, and so on and so forth. But that's still for people who were not born into that or did not dive enough. It's very difficult to reconcile. Kind of like, what do you mean? What do you mean? Now my release will be rolled out in 5 different regions without me doing anything but committing to Git. Come on.
Yeah, exactly. It's like, well, what if something goes wrong? What if blah, blah, blah? Like a lot of the things that I'm speaking about myself as well as like these command line junkies, right? Like for me, it's like, well, like I need to be able to SSH in and take a look and blah, blah, blah. And it is a paradigm shift. It's like, okay, I make a Git commit and everything gets updated. Like my entire production gets rolled out just for me merging this. I understand them. Like you said, it's a paradigm shift in your head. I'm like, oh, wait, I'm delegating my control over to this automated process.
The major difference, at least from my perspective, and what counterbalances that fear is that I have very, very high, I cannot say 100%, but high certainty that I know what's going on. There is no Joe who did this or that on his own from his bedroom, 3 o'clock in the morning. Nobody knows what Joe did. It's in bloody Git. It's in Git. I know what it is. I cannot care less who did what. I know where it is. I can find it, right? And we never had that before in practice. I mean, in theory, yes, of course. I mean, with Chef and Puppet, for example, right? We had that logic as well. It's just that I feel that it never went this far in practice, in implementation. That kind of. Now I'm almost completely confident that
We're almost all the way there. Yeah. Like who or why and when something was changed. And because now we have the technology, right? With GitOps, people's like, oh, like for me, like my opinion of GitOps is like GitOps is something we've always wanted to do, but just now we have the technology to do it. We did pieces of it, but now we just have all this technology is available to us to now we can just start doing. I feel the same way about platform engineering, right? It's like platform engineering is just a new word of stuff. I'm like, well, we were already doing kind of that stuff, but like now there's like a word and process to it, and like it actually means something. Now we're just putting a definition to it. Like we've already been doing some of this stuff and we're just formalizing it now. So that's kind of like what GitOps is in general. We're doing a lot of this stuff already. Like to your point, you're saying like 1, 2, and 3, the 3 principles, most people were already doing all of that already. It's just kind of like that last mile of like, okay, continuously reconciled, meaning like there's a GitOps controller there just constantly watching and, reverting changes and applying new changes for you. And your interface now has changed. Your interface is going from SSH then to kubectl, but now your interface is Git, right? Now your interface is a source of truth. Now your interface has changed. It's like the abstraction has gone along. And to do full-blown GitOps, you're doing all 4, but you don't have to start full-blown all 4, right? You can slowly adopt these things as it makes sense to you. There's a talk by one of our members, Pinky Ravi, who used to work at State Farm. She did a talk about how they adopted GitOps at State Farm, and it's just like one principle at a time, just like a little bit at a time. And like as long as you have your North Star. And that's really what the GitOps principle is meant to be, right? It's like this North Star of kind of like where we want to be as end state. There's been a lot of people criticism, and I think rightly so, about they're just principles, but they're not like best practices. They're not reference architectures. There's really like not a lot of that. I think there's pieces of it around, but really Open GitOps was less about telling you how to do something. They're declarative, essentially. It's kind of like the play on words on GitOps is adhere to the GitOps principles. This is your declaration. This is where you want to be, a North Star, essentially.
The part that I would disagree with both of you is actually I feel that the biggest obstacle among those four is actually the first one, declarative. Show me a company, at least until recently, that didn't have some shell command written somewhere that was executed under certain conditions or whatever, right? Honestly, I haven't found a company yet that is fully declarative, right? Or at least very few. Not as we cannot do it. We definitely can do it. But I feel that actually that's the biggest obstacle, right? Pooling, yes. That's more like a technical thing. Can I pool? Yes, I can, right? Can I store everything in Git? Yes, I can, including commands, right? Including markdown files. So shell scripts or whatever.
It's kind of weird to think about it because, like, if you really think about it, especially with Kubernetes, like you have YAML, but like deep down, the controller is written in Go. So eventually there's some imperative tasks somewhere.
That's more towards reconciliation, right? Of course, there must be some code that converts your desire into reality, right?
Exactly. And it's really like where, and I mean, I agree to the point where it's like, I don't think there's anyone out there who's fully declarative. Like you said, we can't do it. I think it takes a lot of work to be fully declarative and a lot of trust in your systems to be fully declarative. For instance, like there's not a lot of tools. I think I've seen one, but there's not a lot of tools that do schema upgrade declaratively. I don't even know if that's, I mean, whoever's listening, if you want to tag me later on Twitter or whatever, prove me wrong. But like, I don't really see a way to do like something like, there are events where it's like, oh wow, like you need to handhold something like as simple as a database schema upgrade, because it's hard to revert back. Because once you're on that schema, you fall back by moving forward.
I think that's the important part. And I mean, I'm not sure exactly whether that would apply to Akuit. It certainly applies to where I am and stuff like that, right? The goal is not necessarily to be 100% anywhere. It's not about doing everything declaratively, doing everything GitOps, or, just as, I'm freak about testing. Test-driven development is my thing. And I also equally freak out when people tell me, no, testing is don't do it, right? As when I hear, oh, we're going to test every single line of code. You won't, right? It's not practical. It's not always. It's not about being able to use GitOps for 100% of the things. It's about understanding when that is beneficial and when you should just take a shortcut, right?
Yeah. Well, and also it's end goal, right? What's the end goal? The end goal really is to have a system that is predictable and reliable, and you be able to recover it's functionally the same. Doesn't have to be exactly the same. This is kind of where, I had a discussion with someone and I'm like, well, there's abstraction everywhere. Like who's doing more GitOps, me storing a deployment or you storing the pod definition? I mean, I can argue that you're closer to GitOps because there's an abstraction. I'm using the deployment abstraction while you're actually managing pods, but that's not the point, right? That the point is not to be like stickler of GitOps and, take it from a philosophical standpoint, but it's really functional where it's like, I want this system to be functionally identical. For instance, like if you're in AWS, I could tear down EKS cluster and spin up a new one. It's literally a different cluster, but if I apply the same YAML manifest, it's functionally the same, meaning like to me, interacting with it as an end user, right? Like interacting with the application that's running on that, I see no difference because it's functionally the same. And you're right. Like even at Acuity, there's things, I mean, you're managing a system. There's things you're doing imperatively. There's things where you're just dropping in. Database migration is still like an event, right? Like there's certain events that you do that like you just have to, you take downtime and and do them because they matter to do it, slowly first. But the goal is the end state, right? I want my system to be functionally looking like this. I don't have to store everything about it. I just want it to be functionally the same. I want it to look and feel like the original, but it doesn't have to be exactly like the original.
If you're asking yourself, what if something goes wrong? You've obviously not worked in tech very long. The question you should be asking yourself is, what am I going to do when something goes wrong? And if you don't have the plan, by listening all through this, If you're using Argo CD, what you would do is you would shut down reconciliation and break out kubectl apply. Because, yes, it's not what it's doing under the hood, but effectively that's what it's doing under the hood.
As long as you push those changes back to Git so that when you turn it on, it's that example of daddy's home, kind of like better. You can do whatever you want while I'm not home, but kind of by the time I come home, it
yeah, exactly.
As I left
this room better be cleaned up. Yeah, exactly. Yeah. It's like, I'm going to go to work. Yeah, I don't care when you clean up your room, but when I get home, I want the room to be clean. Yeah, that's a great analogy. I like that. Yes. I think with everything in tech from beginning to like, I think eventually forever, is always test your backups, right? Always test your disaster recovery plan. I think going through those motions, doing it in a controlled way will help you later on when stuff actually goes down. Because that's always important.
It's not if, it's when.
It's when. That's absolutely. It's when something will go wrong. Back when I was managing systems, I would restore stuff from tape, and I always thank myself for being like, I'm glad I tested some of these backups, because I just the process. You're not caught up in the process. All right, what do I do next? All right, what do I do next? It's like you already kind of mentally mimed it a little bit. So when something goes wrong, make sure turn off reconciliation, kubectl your way all the way down. But as Victor said, and I'm on Victor's side here, as long as it's reflected back in Git, when you turn on reconciliation, you're fine. The GitOps police isn't going to come knock at your door if you're doing break glass scenarios. It's fine.
So all of Christian's contact information is going to be down in the episode description. Christian, thanks for being with us today.
Thank you. Thank you very much.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.